Everyone, the question is, there is a straight line that is normal to the curve y equal to x cube minus kx at two different points, then the minimum value of k. Here what we need to understand is, in case of cubic function, we definitely have one point of inflection, that is for sure, and exactly one point of inflection. And in some cases what happens is, normal a line passes through point of inflection can be, not always, can be a normal to this curve at two different points. So this is P, which is point of inflection. In this case, let me find that. What will be y dash? Y dash is 3x square minus k. Y double dash is 6x. If I equate to 0, I will get x equal to 0. Substitute in y, I will get point of inflection. Point of inflection. Point of inflection is 0, 0. So this is 0, 0. Okay. Now, this line, I can take it as mx. This is taken as mx. Okay. This curve line is taken as y equal to mx. And what is this curve? This curve is y equal to x cube minus kx. Okay, so far clear. What you need to understand is, a line which is normal to the curve at two different points will definitely pass through point of inflection. Okay, the straight line that is normal to the curve at two different points will always pass through point of inflection. You may think why it is happening like this, because you see derivative. What is derivative? A quadratic. Its graph will be like this. What is this point? This point is the, for this one it is 0, 0. Correct? Okay. 0 comma k, 0 comma minus k. I am drawing the graph of y dash. Okay. So you can see that the x coordinate of this vertex is the x coordinate of the point of inflection. Correct? Because if I differentiate y dash again, I will get this x equal to 0. So the logic is, from the vertex, if I travel a units to the right, a units to the left, I will get same y value. Okay, y value. In this case, it is y dash value. Y dash value means slope. So there is a chance that you will have dy by dx same. Okay. So from point of inflection, there will be a point where dy by dx equal to another point here somewhere. From this I traveled here, and here tangent I have, here also I have tangent. Both tangents are parallel. Why it is like that? Because its derivative is a quadratic function, and quadratic function is symmetric about its vertex. That's why. Okay, so that's the reason we say this normal will passes through the point of inflection. Okay, now what to do here? Y equal to mx is the point of inflection. Let me take this point. I have a and b. Take any one of them as x1 y1. Okay, any one of them is x1 y1. So tangent at a, a is taken as x1 y1. Okay, passes through what? It will, not tangent, normal. Normal at a x1 y1 passes through point of inflection. Why it passes through point of inflection? Because it is also a normal at another point. Normal at a is also normal at b. Because of that, this normal will pass through point of inflection. That's the logic. Okay, now a I took it as x1 y1. What is dy by dx at x1 y1? dy by dx at x1 y1 is 3x1 square minus kx1. This will be equal to, what is the line here? This line I took it as y equal to mx. Why I took it as y equal to mx? Because it passes through point of inflection. So I equated this slope. What is the slope of the line? M. So what is the slope of the tangent at a? Dy by dx is 3x1 square minus k. So if I equate the slope, I will get m equal to minus 1 by y dash. Okay. So what is m? M equal to minus 1 by 3x1 square minus k. I am cross multiplying. What I will get, 3x1 square minus k equal to minus 1 by m. x1 square equal to 1 by 3 into k minus 1 by m. Okay, so we got one equation. How we got this equation? We took the normal as y equal to mx because it passes through point of inflection, which is origin. Now its slope is m, that is equal to dy by dx at a. Okay, so we got this. Now what is the next step? Next step is the a will satisfy y equal to mx, and a will also satisfy y equal to x1 square minus kx1. Okay, these two equations are satisfied by the point. Why it is satisfied? Because a is the point of intersection of y equal to mx and this curve. Okay, so now I can equate mx1 equal to x1 square minus kx1. I can cancel x1 and x1. So I will get m plus k, correct? M plus k equal to, no, there is a problem. This is x1 cube, okay? So this is cube I will get, okay. Okay, y equal to mx1 and y equal to x1 cube minus kx1. So mx1 equal to x1 cube minus kx1. I am cancelling x1. I got m equal to x1 square minus k. From there, what is x1 square? x1 square will be m plus k. Okay, so I got the second one. Now this first and second, these two I am using, and I will get m plus k equal to 1 by 3 into k minus 1 by m. So we eliminated the x1 variable. Now cross multiply, 3m plus 3k equal to k minus 1 by m, multiply by m. So what we will get, 3m square plus 3km equal to km minus 1. This is equal to 3m square plus m into 3k 2km plus 1. Now what is this? This is a quadratic. Okay, this is a quadratic in m, and m is real. So discriminant will be greater than or equal to 0. So 4k square minus 12m greater than or equal to 0. Okay, sorry. 4k square minus b square minus 4ac 12 will be greater than or equal to 0. K square is greater than or equal to 3. Now here k square greater than or equal to 3, two options are there. K is less than or equal to minus root 3, or k is greater than or equal to root 3. Okay, now you see, if k is negative, what will happen? Y dash, what was our y dash? 3x1 square minus k. Okay, this will be positive. Y dash positive means how will be its graph? Its graph will be like this. Okay, strictly increasing. In this case, we will not have a figure like this or scenario like this. So k cannot be negative. So k should be positive. So what is our final answer? K greater than or equal to root 3. Okay, so minimum value of k is root 3. Root 3, that's the answer. Root 3. Okay. So this idea you should understand. What? A normal with a line which is normal at 2 points means that normal or line will pass through point of inflection. Similarly, for tangents also it is true. From a point you can draw exactly 2 tangents to a curve means then the tangent is also passing through point of inflection. Okay.